Problem 15 is asking us to graph r equals 2 plus 3 cosine theta. Same process as before. We're going to make a theta, we're going to make an r, and we're going to find our zeros. So if I go ahead and plug into 0 for here, I end up getting cosine of theta is equal to negative 2 over 3. So again, this is kind of a weird value, right? There's not necessarily an exact value for this that we know. We know square root of 3 over 2, square root of 2 over 2, 1/2. We know values like that for finding theta measures. But cosine of negative 2 over 3 is kind of an odd one. But it does fall within a unit circle. So again, keep in mind that cosine has to be negative in the second and third quadrants. So that means that there is going to be two values associated with this, and we need to find those zeros to be sure. So cosine of negative 2 pi over 3, let's see, so at 2 pi over 3, that would be negative 1/2, and this is a little bit greater than negative 1/2. So that means that it probably falls somewhere around here. So that's just kind of a rough estimate, but what that tells me is that in the second quadrant, cosine of theta is going to come back around to a 0. So I'm just going to denote that theta is equal to cosine inverse of negative 2 over 3. And I know that's going to come around to 0. And because I know that cosine should be negative in the third quadrant as well, I'm also going to make another note here. I'm going to say that this is just going to be another value, that it comes back around, and it also hits 0 at another point in the third quadrant. So these are two independent points that will hit at some point. But we know that we should at least hit them in the second and third quadrant. So let's graph some points around it, and let's see if we can figure out exactly what this graph is going to do. So 0, pi over 2. I know that this value should be between pi over 2 and pi, based on my graph, because again, I know that this is going to fall within the second quadrant. I know that this one will fall within the third quadrant, so I'm just going to write 3 pi over 2 around it, and 2 pi will be my last point. So if I plug in 0, I end up getting a radius of 5 in this case. If I plug in pi over 2, I end up getting a radius of 2. I have my cosine inverse of negative 2 over 3. So that tells me that I should have a radius of 0. If I plug in pi, I end up with a radius of negative 1. Cosine of 3 pi over 2, that tells me that it should be radius of 2, because cosine of 3 pi over 2 is 0. And 2 pi gets me right back to 5. So let's go ahead and let's try to graph this shape. So at a theta value of 0, I have a radius of 5. So my radius is really far out there. Pi over 2, I have a radius of 2, so it's a little bit more condensed. So again, I'm going to try to graph this to the best of my ability. Cosine inverse of negative 2 over 3. I know that when it hits this point in the second quadrant, it's going to come back to 0. Now again, I don't know exactly where that point is. It would take a little bit of time to isolate it, but in this case, because time is really valuable on an exam, I'm going to make a rough estimate, and I know that it's eventually going to come back to 0 at some point in the second quadrant. So I'm just going to make a rough sketch here, say that it does come back to 0 eventually. Now, when I hit pi, I have a negative radius. So if my pi is in this direction, so pi with a positive radius of 1 would be somewhere around here. But because it's negative, it's going to be flipped on its axis. So that point is actually going to be somewhere around here. So that means that I'm going to have one of those inner loops going on. Now, I know that cosine of negative 2 pi over, cosine inverse of negative 2 over 3 is going to be another 0. So that tells me that I'm going to come back around and I'm actually going to intersect 0 again. So that creates that inner loop. And again, I knew that because this should be in the third quadrant. 3 pi over 2 is going to denote it as 2. So I'm going to come back around. I'm going to hit 3 pi over 2. And when I hit a value of 5, I'm going to return back to my original starting spot. So I end up getting a shape with a little inner loop. There are only 2 shapes on your page that do that. So the answer has to be A, because this is the one that is centered around the x-axis, which makes sense because this is cosine. So stuff with cosine is usually centered around the x-axis. Stuff with sine is usually centered around the y-axis.
The Teaching Center, UF's Learning Resource Center.